One of the conversations that we've been having over on Discord, that's one of the more interesting ones, is talking about artificial intelligence and how the AI works in this game, et cetera, et cetera. For those of you who don't know, I've been making games for well over 20 years, and I've been involved in making designing the structure for how the games think about things for literally dozens of games. And for a lot of games, like the hidden object games that we made, there's not really any AI to speak of. Every game has some level of AI because people don't really understand what AI is. They think it's some sort of nebulous thing, like, oh, does this game have AI? All games have and don't have AI. AI is just a thing that we talk about where the game is going to make some decisions, right? And when a game makes decisions, sometimes that decision is really, really easy for the game. For instance, I have a game where I push a button, and when I push a button, it's going to do this thing. That's the decision that the game made. Did somebody push the button? Yes? Okay, I'll do that thing. And I know the astute amongst you are saying, but wait a minute, that's not a decision. You just told it what to do. Aha! This is actually the point. We always do this. Computers don't have, and this gets into a very metaphysical question about whether or not humans have the ability to actually make decisions, or are we just purely responding to stimuli. But in the case of computers, we know, because we built them, that they don't actually have the ability to think outside of the structure that we have given them to think in. When you see a computer make a decision, it's not actually making a decision. It is doing exactly what you told it to do, but we have obfuscated its being told what to do to make it look like it's making a decision. And I'll give you a very interesting example of this. I was involved in planning the AI for the very first Far Cry, which was a game that was thought of quite well for its AI by many people. And the interesting thing about a first-person shooter is the core thing that an enemy is going to do in a first-person shooter is shoot you, right? And it's not hard to teach a computer how to do that, right? You tell a computer, if you see enemy, if you can draw a line between you and the enemy and it is within range of your weapon, then aim weapon directly at enemy, fire trigger until enemy is dead. This is the simplest AI anybody will ever write. Problem is, it's no fun because you walk around a corner and immediately you're dead. And you're like, fuck, what, this thing killed me? This AI is too good. It's not good. It's just a simple set of rules that the AI is following that says whenever I have a sight line to you, put bullets into you directly into your head and get nothing but headshots until you die. Computers are good at that. They don't have any problem with that. It's just math, and computers are good at math, right? So the challenge in making an AI for a game like that is not actually making it good. It's making it seem kind of good without absolutely destroying and wrecking you every time it sees your character. Because we can make, trivially, we can make an AI in a first-person shooter that just ganks you and just, gets right on you. So what we end up spending all of our time on is how do we make the enemy miss in a way that's interesting? How do we make the enemy not get in the right place? How can we make you actually the hardest part of making the AI for a first-person shooter is making it seem stupid. Or stupid is the wrong word. Making it seem human. Making it seem like it's making the kind of mistakes humans make. Like, coming out of cover when it shouldn't come out of cover. Because the AI, of course, the computer knows exactly where you are. When it ducks behind something and can't see you, the computer still knows where you are. It's a computer. It's computing where you are, right? It has all of that information at its fingertips. So I could have every enemy, even the ones that couldn't see you, come right where they need to be. And, I could do all that. That's trivial to do because the computer has all that information. Making it seem like it doesn't have that information is actually the challenging part. Now, we're not making a first-person shooter. Obviously, we're making a strategy game. And the artificial intelligence for a strategy game is different, but it has some similar challenges. And I want to start from sort of the basic challenge of a strategy game AI, which is how does it figure out? I mean, you can look at it from two different directions. You can look at it from the top down or the bottom up. From the top down, how does it make a grand strategy? How does it decide, I'm going to do this thing? Like, if you were playing a game and you were figuring out what you were going to do, you might make a decision like, right now I'm going to go explore and take some territory, and I'm going to pull up a game while we talk. There's the game. All right, so here's the game, right? So let's say I start a game. So one of the first questions that the AI might ask is, okay, I just started a game. What do I do? Right? And there's a lot, as a player, there's a lot of decisions you could make. You could say, hey, you know what? I'm going to build a ship, and I'm going to go out and I'm going to use this ship, which has a long range, to go explore the coastline and find some places where I can build some stuff. Oh, it looks like maybe there's a fort over here. Maybe I'll go take that fort. That's a reasonable decision that a player might make at the beginning of the game. Another reasonable decision a player might make is, hey, why don't I build these traders right here and actually, why don't I build these traders right here on these docks and have them make some money, because making money would be a good thing to do at the beginning of a game. That's a reasonable decision to make at the beginning of a game. Another decision that the computer might make, or a player might make, maybe I can build these. Oh, who's got the cheap building ability? These support wagons. Build cheap. So I'll build these support wagons here, and I'll build with my support wagons on the next turn. I'll build a tower. Now remember, on all of these things that I just told you, the thing that I'm gonna do, whether it's go explore the coast, or whether it's build this tower, or whether it's start using my economy bonus to get more money, none of that's going to happen on this turn. That's all going to happen on next turn. So the computer has to have some sort of plan that it's going to fit its actions into, right? So you have sort of a grand plan. So right now, for the moment, let's say that the computer had figured out that its grand plan is, hey, I don't have enough money. I need to make more money. What I'll do is I'll build some settlers, and I'll build a farm, and I'll use the farm to make more money because I need more money. Well, how did the computer get to that point? How did the computer decide, you know what, my problem right now is money? Because there's other problems the computer might have. Maybe I'm being attacked by somebody. Maybe I'm being threatened by somebody. Maybe I feel that my fog of war is too close in, and I don't know what's going on, and that frightens me. There's all kinds of things that a player might think at the beginning of the game. And the question is, how do we decide which one of those things the computer is going to emulate? Now remember, the computer has to emulate this. It doesn't actually have to do this because it doesn't need this. The computer knows where every single person in the game is. It's the computer, right? I mean, it's the thing that's computing all of that. It knows where all the players are. We have that information. It knows exactly how strong all the other players are. It knows how much gold everybody else has. It doesn't need to explore the coast. It knows what's along the coast. It's the one drawing the coast, right? So there's a bunch of sort of things that we have to convince the player that the AI is thinking about or doing, so it's behaving in what we seem as a rational manner. Now, let's go ahead and turn and build my little settlers right here. Now we could look at it from the other direction, which is the bottom up, and ask, okay, where's that unit going to move? I got this settler right here. Where's he going to go? What's he going to do? Is he going to move over here? Is he going to stay here and build? I mean, I got a bunch of choices with this guy. And right now, there's not a lot of choices because I don't have any enemy threatening me. But if I had some enemies coming at me, I would have choices like, do I attack that enemy? Do I run away from that enemy? Do I stay here and defend? Do I build something here to do something? There's a whole series of things that this one unit could do. And the question is, how does that thing that the unit is going to do fit into a grand strategy so the AI looks like it's doing something that makes sense? This is the challenge. Now, in a game like chess, let's go to probably the simplest strategy game I can think of. Chess has a very limited set of moves. If I've got a rook, there's only like 4 things the rook, well, there's actually only 2 things the rook can do. He can move that way or he can move that way, right? I mean, that's what he's got, right? And so I could say, does he move here, 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 or here? Does he move here, 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 or here? Pretty limited stuff. Now, it may seem like a lot, and if you start doing the math, I could move my rook, or I could move my knight, or I could move my pawn, and which one do I do? It seems like a lot, but actually in the world of strategy games, chess is relatively simple because it has a very limited move set. And this is why some of the best AI that was written for games was written for chess. Also because chess is quite popular. our game has a lot more options. Right now, this guy can move any one of those locations. Um, I can heal somebody. I can build something. I can look for treasure here. And this is important. This isn't a game where like I move this and then I figure out what else I move at the same time. At the same time I move that guy, I also have to think, well, I'm also going to move this guy. And so once you start multiplying out, okay, option 1, he moves here and he moves here. Option 2, he moves here. Option 3, he moves here. Okay, now let's try him moving here with him moving here. Now him moving here. If you start multiplying that out, the brute force approach that chess uses, most chess AI uses what's called a brute force approach, which basically says, if on this turn I move here, how do I think he'll move? Then how will I move? Then how will I move? And I'm just going to butch through a couple million decisions. This is why you need big supercomputers to play good chess games, because basically it's just butch throughing all of those possible decision networks until it finds the one where it wins the game the most times. We can't do that. That's physically impossible. Well, it's not physically impossible. With the computing technology that we have available to us today, you can't do that with this game. So we get into a different way of doing AI. And this is actually the way that a lot of people are programming AI for games like chess and stuff now, which is a more advanced way of doing AI, which is saying, okay, why don't you set yourself some goals? So we know, for instance, that the AI has gold that it cares about. We know that it's got PopCap that it cares about. We know that it's got victory points that it cares about. So those are sort of 3 things that I can track and say, all right, right now I've decided you're interested in blah. How did I decide you're interested in blah? Well, I can look at your gold and say, well, it looks right now like I got more control than I need. I'm only using 2 of my 11 control. It looks like I'm really only using, very little of my gold. I got 63 of a possible 72 gold. Right now, I could very clearly look at that, put it through some sort of decision-making metrics and say, when I have plenty of gold and plenty of control, I ought to build a unit. There's a very simple decision that I can give the computer. Now remember, the computer didn't decide anything. There's no brain in the computer. It's simply looking on a metrics and saying, when I have plenty of gold and I have plenty of whatever, go ahead and build something, right? So now it says, well, what am I going to build? Well, maybe it's going to look and say, well, I don't really have a lot of area explored right now. I probably want to go out and explore some more of this darkness around me. I'm going to go look at my units. What's a good unit for exploring? Well, looks like this cavalry has a lot of moves. I should think about using that, right? Well, how about the ship? The ship has a lot of moves. I should think about using that, right? How does the computer know that? Well, it knows how many moves these things have, so it can kind of make that decision. But how does it know? Does it build the sloop or does it build the horses? Now, we can create a very complex sort of network of decisions based on, inspecting each one of these cards and stuff. But there's another way we can do it, is we can help. As designers, we can help. So what I can do is I can start saying, hey, you know what? There's not really that many sort of states that the computer is probably going to be in. And I can probably define some of those states. Right now, he's probably in an exploring state. Later on, maybe he's in I've got way too much gold and not enough PopCap, so I want to build PopCap buildings. Maybe later on it decides I have way more control than I need, but I'm gold bound. Maybe I'm in a state where I need to make more gold buildings, et cetera, et cetera. So we can look at those things and kind of create an attitude for the AI. What is it that I want right now? So let's, for the moment, say that it's decided, I've looked around and I've noticed that I'm on a coast and there's a whole lot of sea and I want to explore. So I'm going to set you in mode Sea Explore, right? And once you're in mode Sea Explore, it can go look at its unit list. And I can actually make this a lot easier as a designer by starting to tag the units. And so I might have given the unit of Sloop as a really nice Sea Explore unit. So maybe it's got 10 points as a Sea Explore unit, where obviously the militia, who can't even go in the ocean, has 0 Sea Explore units. So right now the game says, hey, I'm in a Sea Explore kind of mood. What have I got? I'm building something. Oh, that's my Sea Explorer unit. Great. let's build a ship. Now wait, looks like there's a couple different places I could build that ship, right? Now it has to start looking at, well, which one of these is the least threatened place? Maybe there's an enemy over here and I want to build it over there. Maybe I can see on the edge of this fog of war, there's somewhere I want to go right there. So it says, hey, why don't you build a ship close to that? So we can start building these sort of decision-making frameworks. And it says, all right, I'm going to build a ship. I'm going to explore with these guys because I haven't done very much. And you know what? Is that a civilian? That's not a civilian. So he's gonna say, all right, I need to build some more units. So why don't I build these chain gang right there? Boom. So now he's decided I'm ready to explore. Throw some exploring units out. The units that I've got, go out, expand my fog of war. Go see what's there. Now keep in mind, the computer knows what's there. The computer's what's drawing what's there. But we have to tell the computer not only what he wants, but we also have to tell him what he knows. So right now, we specifically have to tell the computer, you don't know what's in this dark area, right? And the nice thing is the computer doesn't cheat, right? I mean, if you tell it you don't know it, it doesn't know it, right? So right now, it doesn't know that world out there exists. So it thinks, I've only got 50 hexes of known space. I'm going to go out and do some more, right? All right, now I've got my exploring units. Hey, how about this ship? Where am I going to go with that ship? I think I'll go check out over here. This guy's again, we have to get into the question of how does it know where the ship's going to go? I mean, it could go anywhere, but maybe it looks and says, there's something on the edge of my fog of war here that's interesting. There's a coast I can see there. That's an interesting direction to go. All of this has to be coded. I could go on to this in huge detail. I probably would bore a lot of people, but I wanted to kind of give you a beginning of the sort of challenges that we face. And when people say the AI in this game is dumb or smart or whatever, these are the kind of challenges that we are, working with, trying to figure out what is and what isn't going to work. It's a lot of work, and it's probably what my life and Adrian's life is going to look like as we build this game. And one of the big challenges of AI is you can't get to this point until you've got a game that's already pretty well put together. All of the decisions and things that I just talked about, they don't exist until the game is in a solid enough state that you can start making those kind of decisions. For instance, until 2 weeks ago, we didn't have to pay money for powers. That wasn't the thing. Now we have to pay money for powers. That's a thing now. I wouldn't have coded that into the AI if we had written the AI last week. So there's sort of a path that you have to go step by step by step. And at each one of these steps, there are things you can do and there are things you can't do. And one of the things that we have not been able to do up till now is put any serious time or effort into the AI because we needed the game to be in a state where the rules were clear enough and sort of solid enough, and we believed that they weren't going to change enough, that we could go in and start saying, all right, this is the rule set. This is what you know how to do, what you don't know how to do. Now we can start telling you how you should behave.